Hi guys, it's Mrs. Bradfield again, and we are going to start 11.4, but we're going to break this up into two parts because they're kind of difficult concepts. Can be difficult. We're going to try to make them as easy as possible though. So our first part is finding the area of regular polygons. So when I say regular polygons, remember that means a polygon with all congruent sides and all congruent angles. So a polygon that does not have all congruent sides would not work this way. So we're going to find their area. And it says that the central angle of a regular polygon is equal to 360 divided by n being the number of sides. So when I talk about a central angle, for instance, I'm talking about this guy right here. That's a central angle. And so if I were to put a circle around my pentagon here, so we're really talking, the polygon is our pentagon. If I were to put a circle around that, you can see that it's a circumscribed circle. All the way around that circle is 360 degrees. So that's where 360 comes from. And then n is the number of sides here. So in this case, we have a pentagon, which is 5 sides. And you can see if I were to draw in all of these links here to the vertices, that I would have 5 triangles, and which would all have the same central angle because they're all congruent. So that's why I divide by 5. But if I take 360 divided by 5, that's going to be 72 degrees. So for this pentagon, that central angle there that I've got marked is 72 degrees. And so that's how we find that central angle. We've got a few different parts that we need to look at other than what the central angle is. We have what's called the radius. So the radius is this guy right here. Okay, the radius is any segment that is drawn from the center of the figure to a vertex. And you can also see that that's the same as the radius of that circle that's around the pentagon. I have 5 that I can draw here because I have 5 vertices. So here's another radius, here's another one, here's another one, and here's another one. And those are all radii of the circle, and they're all the same length. The sides of my figure, which it's gonna refer to every once in a while, we have 5 congruent sides there. So AB is one of them. Then we have BC, CD, DE, and EA are all the sides. And we have something called the apothem. The apothem is really the height of each one of these triangles. So it goes from the vertex of the central angle and is perpendicular to the side of the pentagon. So that's my apothem. All right, so what we want to do in example 1 is just go through and identify the parts that we're looking for. It says, for the square FGHJ, it's inscribed in circle K. Identify the center. So the center is obviously the center of the circle as well. That's K. So the center is point K. The radius, or a radius, anything that starts with K and to the vertex of the square. So we've got a couple of radii drawn there. So we could say KJ, or KG, or KH. Those are both radii. And apothem. So the apothem is, again, a segment that is drawn from the vertex of the central angle, which is K there, and is perpendicular to a side. So KL is going to be our apothem. And then a central angle of the polygon, there's one drawn in, and our central angle is this little green guy right here. And so that's angle GKH. Remember that the vertex of the angle has to go in the middle when you're naming that. Then it says find the measure of the central angle. So we have our square and we have that circle. So we have just one angle here. If I drew in all of my radii, I would also draw in KF and KJ. So I have 4 central angles that I can draw with the center and the radius. So I'm going to take the measure of that central angle, which is GKH, is going to be 360, and then divided by 4, which is 90 degrees. So that's my central angle, and there are the names of all of the parts. Example 2, we want to find the area of the polygon. And so we've got a little bit of information here. It says that we have a window here. We can see that it has 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. And it's a regular octagon. And so it would actually have 8 of these little triangles. There would be 8 of these guys. So we're just going to focus on the 1. In order to find the area, one of the ways we can do it is to take the area of one of the triangles and multiply it by however many triangles there are, so number of triangles. As long as those triangles are congruent, which they are in this case because it's a regular polygon, we're good. If the triangles were different sizes, then we couldn't do this. So in this particular figure, we have a triangle, looks something like this. This is 15 inches, which is the base, and the apothem is 18.1 inches. Well, I can easily find the area of that triangle because the area of a triangle is 1/2 base times height. So I have 1/2 times 15 times 18.1, and I want to find that value. So if you want to put 0.5 in for 1/2, you can do that. 0.5 times 15 times 18.1 is 135.75. And my writing is pretty rough today. Hang on. And that's actually inches squared. So that's the area of just the triangle that's highlighted in the picture. Now, if we want the whole area of the octagon, then we're going to take that triangle, which was 135, maybe here, which is 135.75 times 8, because there would be 8 of those triangles since it's an octagon. And so the area of the octagon is 1,086 inches squared. Okay, that's one way to find the area of a polygon, is just by let's see if I can give us a little bit more room here. So that was one way to find the area of a polygon, is to multiply the area of the triangle by however many triangles you have. Another way, and this is very specific to a regular polygon, given some certain information, is to take 1/2 the length of the apothem, which there's your apothem, times the perimeter of the whole thing. So we're going to take 1/2 the apothem times the perimeter. In example 3a there, it says find the area of the regular polygon. We have a hexagon here, and if we're going to use area is 1/2 the apothem times the perimeter, I'm going to find the perimeter first. Right? That's going to be pretty easy. It's a regular polygon. You can see that AC is 3, so all the way around is going to be 3 meters. And so I have a hexagon, so I'm just going to take that 3 meters times 6, and that's 18 meters. So I know I'm going to use that. Then I need to find the length of the apothem. I don't have that yet. The apothem is segment BD. So I'm going to have to do a little work here. I'm going to take just this half, and you can see that I have a right triangle there, and I'm going to kind of rework that over here on the side. I see that this is B, and then I have C and then D right here. So BC is 3 meters, and DC is half of AC, so that's 1.5. I'm going to do a little Pythagorean theorem here to find BD, which is my apothem. So x squared plus 1.5 squared equals 3 squared. 1.5 squared is 2.25. And then I'm going to subtract 2.25. And that gives me x squared is equal to 6.75. And then I need to come back and take the square root of both sides to find x. So I get x, or A, which is my apothem, get my calculator here, is the square root of 6.75. And that's about 2.6. Okay, so now I have the perimeter and I have the apothem. So I'm going to use my formula. There's my perimeter, there's my apothem, and I'm going to substitute those values in. So I keep hitting the button here. So that gives me the area is 1/2 2.6, which is the apothem, times the perimeter, which is 18. And so the area of the polygon is 23.4. All right, in 3B, this is actually a lot easier than it looks. We have a square there, and if I draw in the other radius, that's also going to be 7. And this forms a right angle, which we learned in a previous example here in this lesson. Because we have a square, we have a right angle there. We also know that the diagonals are perpendicular. So we've got the base and the height then really of this triangle. 7 and 7. The area of a triangle is 1/2 base times height. And so I can do 1/2 7 centimeters times 7 centimeters. And that's going to be 24.5 centimeters squared. Well, that's just this square right here. Well, if I drew in all of my radii, I would have 4 of those. So the area of the square is 24.5 times 4, which is